right, lesson 2.5, compound inequalities. As per usual, let's get started with the hardest problem. Solve the inequality, graph the solution. And we'll have negative 2k minus 16 is less than 4k minus 16, or 19 plus 4k is greater than 15k plus 8. So, see if you can solve that. If you can, if you can't, that's okay, because by the end of this lesson you will be able to, and at the very end of it I will be going over this one. So, if you want to try it, pause right now. If not, then we shall move on. So, how I did this lesson, we're going to be trying something a little bit different, where we went to our student journals, and I tried to have you see if you can figure out, for these 4 problems, I guess these 8, of A through D, let's see, of A through D on this page, page 48, and then A through D on this page, page 49. For all 8 of these, you are supposed to see if you can figure out what the 2 inequalities are supposed to be. If you remember from doing inequalities, where we have, for example, something like this, we have our number line. Let's say it starts at 2, open circle, this way. You know how to write the inequality for this one, right? We have 2, open circle, so it's not equal to, so there's no line. And if we have the graphed line as x, it is all the numbers greater than 2. So now, with this, all 8 of these are going to be 2 inequalities. It might be easier to see for these ones that there are 2 inequalities, but they're also the same for these ones. So if you can, I'll ask you to pause, see if you can figure them out on your own, and then I will start going over them. So for this first one, same exact steps as when we figure out one inequality. What numbers do they start at? Here we have a negative 6. Here we have 3. So one inequality is going to deal with negative 6. One inequality is going to deal with 3. Let's start with negative 6. Let's just say we have our graph as x. Is the x, the shaded part of the line, is the x greater than negative 6 or less than negative 6? Is the shaded part covering all the numbers that are greater than negative 6 or less than negative 6? Greater than negative 6. So x is greater than negative 6. And what about the other side? Or it's closed circle, so it's equal to. Other side for 3, it's an open circle, so not equal to. And x, the shaded part, is covering numbers that are smaller than 3. So x is less than 3. And I'll explain this in a second, but we have our 2 inequalities, and there's going to be an and between them. So x is greater than or equal to negative 6, and x is less than 3. And we also have these definitions here of half open, closed, open. All they really mean is it depends on, I guess, the end dots, if they're open or closed. Half open, one of them is closed, one of them is open, one of them is open, one of them is closed. Doesn't matter which one. Closed is where they're both closed. Open is where they're both open. Checks out, right? So, let's move on. Here we have negative 5 and 4. So we have negative 5 and 4. I'll preemptively put down my x's on the other side. For negative 5, open circle, so it's not equal to, and x is all the numbers greater than negative 5. And x is less than or equal to 4. Next one, negative 4 and 5. So we have x is greater than or equal to negative 4, and x is less than or equal to 5. For D, we have negative 3 and 6. So we have x is greater than negative 3 and x is less than 6. Now for these next ones, these ones are probably easier to see exactly what they are. Still same exact steps. We have negative 6 and we have 3. We're going to start at negative 6. It's equal to, because it's a closed dot. And the shaded part, which for us is still going to be x, is less than negative 6. So x is less than or equal to negative 6. For 3, open circle, so it's not equal to. And x, or the shaded part, the graph itself, is all the numbers that are greater than 3. So x is greater than 3. And before, we used and to join all of these. But now we're going to be using or to join all of these. There is a difference. Like I said, I'll explain right after going over them. But for these next ones, we have negative 5, we have 4. So the first one's going to be all numbers. So x is less than negative 5, or x is, there's not less, no equal to there, greater than or equal to 4. Same steps for the next ones. X is less than or equal to negative 4, or x is greater than or equal to 5. And last one, negative 3 and 6, negative 3, 6. X is less than negative 3, x is greater than 6, and they're connected by an or. Now, here's where you get a vocabulary definition of compound inequality. What is a compound inequality? Compound inequality. An inequality formed by joining two inequalities with the word and or the word or. So a compound inequality, an inequality formed by joining two inequalities with the word and or the word or. So that's basically what we just did. We made compound inequalities just now. All the way back up here, we have two inequalities joined by the word and or joined by the word or. So these are all compound inequalities. We just made 8 of them. And represents an intersection, an overlap, or both. For example, if we have these two inequalities, x is greater than 2 and x is less than 5. If we just graph them real quick individually, we have 2's over here, closed circle, greater than, so it goes that way. And we have 5 down here, open circle, less than, so it goes that way. If we have the compound inequality, x is greater than or equal to 2 and x is less than 5, what does that graph look like? Well, it is where both of these overlap each other. So you have an open circle at 5, closed circle at 2, and it is where they overlap each other, so right in between. Another way of writing these and compound inequalities, is to combine it into one statement. So if we just have one x, we have the smaller number on the left, so 2, bigger number on the right, so 5, and then writing the symbols accordingly so that it means the same thing. X is less than 5 and 2 is less than or equal to x. So these are the same thing between these two. Meanwhile, for or, it is the union, or they're separate, or it's either. Taking similar examples, we have two inequalities. Let's say we have y is less than or equal to -2, and y is greater than 1. If we graph those independently, -2 over here, 1 over here, closed circle, less than -2, open circle, greater than -1. If we have the compound inequality, y is less than or equal to -2, or y is greater than 1, this is what that graph looks like. Where basically either one of them can be true. Either one of the inequalities can be true. And there's no other way of writing the ors. The ors will only ever have an or. So for and, it's where both inequalities have to be true. The number, x, has to be greater than -2 and less than 5. Or greater than or equal to 2. I say -2. Greater than or equal to 2 and less than 5. So all the numbers that are in between there. Or is only one of them has to be true. Where, because there's no numbers that are less than or equal to -2 and greater than 1 at the same time. So only one of them has to be true. Some special cases, just real quick to address. If, for example, we had something like this, where it was x is less than or equal to 2, and x is greater than 5. What happens if we try graphing that? Well, let's see, we have a line right here, graphing this one at 2, closed dot, goes this way. We're graphing this one here, it would have 5, open circle, this way. And because it's an and is where they both overlap. And do these graphs overlap? No, they never overlap. There's never a number that is both less than or equal to 2 and at the same time greater than 5. That's impossible. So in this case, there would be no solution. Or if we even have something like this, where it's, let me move this up a little bit actually. Where we have x is less than or equal to 2 and x is less than 5. What if we graph this one? Let's choose different colors. X is less than 2, so we have this graph here. And let's do orange. X is less than 5. Open circle, and it goes this way. And is where they both overlap. So, in this case, where do these both overlap? Let me move this down a little bit. They both overlap right here and onwards, basically. So, your final answer for something like this, you would only graph where they overlap. So your final answer for this would just be this line here. Some special cases for or. If we have something like, let's see, y is greater than or equal to -2, or y is less than 1. What happens if we graph that? Move back to my other colors. If we have this, start graphing this one, so at -2, closed circle, greater than. We have this one, open circle, less than. Well, only one of them has to be true, or it's the union of them, if you know what union is. Only one of them has to be true, but if we look, basically the entire number line is covered. Even this hole that we have here at 1 it's covered by being greater than -2. So the solution here would actually be, let's see, move this down a little bit. The graph would be this, that would be your final answer. And the solution is all real numbers. Because if only one of them has to be true, well, where one of them isn't true, the other one is true. When you have numbers that are less than -2, it's covered by the numbers that are less than 1. And all that jazz. Another example, if we have y is less than or equal to -2, or y is greater than 1. Try graphing that to get the purple and orange back. -2, close circle, less than 1, open circle. Wait, did I just do the, I did. Okay, I actually wanted it to be less than 1. So it goes this way. When it's or, you might notice this is a very similar example to the one that's up here, where they overlap, but only in one direction. For this one, because it doesn't need to be overlapping, it's just where one of them is true, everything that is less than -2 is covered by being less than 1. So your final answer on this one would be open circle here, everything less than. Because only one of them has to be true. Only one of the inequalities has to be true. So those are some special cases that you have for the both of them. I'll separate these two just a little bit more. So those are for and. These are for or. I'll even draw a line between them. Now, just like when we first learned inequalities, let me change my colors back. Just like when we first learned inequalities, we went from words to inequality. Now we're going to do the same thing. We're going to do words to compound inequality. I'm going to go through 2 examples here. I'm going to break them up, go through them, and then I'll go through some examples in the student journal. So we have a number x is greater than -8 and less than or equal to 4. So we have to put these words into a compound inequality. Here's how I'm going to separate this. We have a number x is greater than -8. Actually, let's make that bigger. And less than or equal to 4. So we have a number x is greater than -8 and the same number x less than or equal to 4. If I want to write that into one statement, we have x in the middle, -8 over here, 4 on this side. -8 is less than x is less than or equal to 4. If I want to graph this one, my lazy ways, all you really need are these 2 points, -8 and 4. We have a closed dot at 4, open dot at -8. Just to double check that these are going to overlap each other, like I just showed you in those special cases. Sometimes they don't overlap each other, and that changes what our answer is going to be. So just to double check, we have this direction of greater than -8. We have this direction of less than 4. So they're going to overlap each other, which is good. And this is where they overlap each other. As a side note, you can't just do this. Because because this does imply that now your graph says it's this one and this one, which is not true. We're only wanting to graph what is overlapping. Another example, just going to a new page. A number y is at most 0 or at least 2. So let's break this one up again. A number y is at most 0 or, at least 2. So a number y is at most 0. At most means the biggest number it can be is 0. So it has to be 0 or lower. It has to be 0 or less. So it can be equal to 0 or it's lower than 0. It's at most 0. Or the same number y, at least 2. When something is at least something, it is equal to 2 or it's bigger. It's at least 2. You have at least 3 people. You have 3 or more people. So y is greater than or equal to 2. So let's graph this one. Point at 0, point at 2. Closed circle at 0. We have y is less than 0. Closed circle at 2. We have y is greater than 2. And they don't overlap or anything, so I don't have to redraw this graph. This is my final answer. Now to the student journal, the next page. I have you do 1 through 5. So let's walk through those real quick. So you can do them on your own. And then double check by unpausing this video with me going over them. So let's put these up into our 3 parts. Number u is less than 7. This is a little bit bigger. Number u is less than 7 and greater than 3. So we have u is less than 7 and same number u is greater than 3. So for graphing them, let's just put 3 right here, 7 right here. Open circle at 3. It's everything greater than 3, so it goes that way. Open circle at 7, everything less than 7, so it goes that way. Perfect, they do overlap. Where do they overlap? They overlap right here. Next one, a number d is less than -2 or greater than or equal to 2. So d is less than -2 or same number d is greater than or equal to 2. Let's put -2 here, 2 here. Double check which directions they're going in. So if we have an open circle at 2, everything less than goes that way. Closed circle at 2, greater than or equal to, so it goes that way. Perfect, that's all we need. Next one, a number s is no less than -2.4 and fewer than 4.2. So s is no less than. If it's not less than, it has to be greater than. So it has to be greater than. S is greater than -2.4. You might have noticed a cut earlier. I'm going to pause the recording again just to double check something real quick. Okay, I double checked. So it's no less than -2.4, which means it can be equal to -2.4, but it also has to be bigger than. And same number s, fewer than 4.2. So a number s is fewer than 4.2. So this one's also going to be equal to, or can be equal to 4.2. A little bit finicky because it's English. It should be less than 4.2. I'm not going to blame you if you don't have the equal to here because it doesn't say and is, but because of grammar, you're assuming that the same is here also applies to after the and. But this is not English, this is math. So I'm just going to put negative 2.4 here, 4.2 here. Both of them are closed circle. Just to double check where they overlap. Negative 2.4 greater than goes that way. Less than 4.2 goes this way. They do overlap. So this is where they overlap. Next one, a number C is more than negative 4 or at most negative 6.5. So C is more than negative 4. Pretty straightforward. Or C is at most negative 6.5. Same thing as before. At most means that's the biggest number it can be. If that's the maximum it can be, it has to be that or lower. So less than or equal to negative 6.5. Negative 6.5 is smaller than negative 4, so that goes on the left. Negative 4 over here. Closed circle at negative 6.5. C is less than, so it goes that way. Open circle at negative 4. C is greater than, so it goes that way. Now this last one. A number C is no less than 1.5 and less than 5.3. So C, it's no less than 1.5. If it's no less, it has to be bigger than. So it can be equal to negative 1.5. It just can't be smaller than. So it's greater than negative 1.5, and C is less than 5.3. So let's put negative 1.5 over here. Let's put 5.3 over here. And because it's an and, let's double check they overlap. Close circle here, open circle here. C is greater than negative 1.5. C is less than 5.3. They do overlap each other. And where do they overlap? Right here. Now, just like before, we went from words to inequality. Now we're actually solving inequalities. I'm going to go through 3 examples. And then I'll work through some in the student journal, and then that'll be it for the entire lesson. Well, I guess I'll do the hardest, and then that'll be it. So, with these 3, solve each inequality, graph each solution. Instructions are important. So this one wants us to solve and graph, not just solve, not just graph, solve and graph. So we have the first one. Negative 4 is less than x minus 2 is less than 3. So if you remember from when I told you the different ways that you can write the ands over here, where it either says the word and or it's combined into one statement like this, where it has 2 inequality symbols in the same thing. That's what this is. This one is 2 inequalities in the same thing, so this one is an and. What we're going to be doing, our first step, is to split this and into the 2 compound inequalities. Basically, we have one side, one inequality for this side, and the other inequality for this side. So we have negative 4 is less than x minus 2, and x minus 2 is greater than 3. The and is important here. You have to remember if it's an and. And then you just solve the inequalities like you have done before. These both are one-step inequalities, so you can do them fairly quickly. So we solved it, and now we have to graph. If you want to put it into one statement, x in the middle, bigger number on the right, so 5, negative 2 on the left, and using the symbols accordingly. Move this graph down a little bit. Whoops. So if we have negative 2 over here, 5 over here, open circle at both, double checking that they overlap each other. So we have x is less than 5, that goes that way, and x is greater than negative 2, so that goes that way. They do overlap. They overlap in the middle. So basically, this would be your final answer here. Technically, you don't have to put it into the single statement. That would be your final answer. So like -2 greater than x and x is less than 5, and then you have your graph. This is all that I'm looking for. All of these parts are important. You have to make sure you have an and. There's a difference between having an and an or, right? Because if this one was an or, it would end up being all real numbers because they both go opposite directions and they cover everything. Try another compound inequality. We have second one. Your 3 is less than -2x plus 1 is less than or equal to 9. Same exact thing. This one also is an and because it has two inequality symbols in the same statement, so it's assuming both of them are true at the same time. Split them off into our compound, into the compound inequalities. We have -3 is less than -2x plus 1, and -2x plus 1 is less than or equal to 9. Now these are two-step, but you still solve them the same way. Reverse PEMDAS, addition, subtraction first. And your normal inequality rules still apply. Here we're going to be dividing by a negative number, so the sign flips. Dividing or multiplying by a negative number always makes the sign flip. And now we solve the other one. Same exact rule here, because we're dividing by a negative number, the sign flips. So now this is our answer. And our graph would look like this. So we have -4 over here, 2 over here, -4, double check they overlap each other. Close circle here. It's greater than -4 for 2, open circle here. X is greater than, or x is less than 2 if you want to flip that around. So it goes this way, and they do overlap each other. Oops, in the middle. So this is your answer. And if you're fancy, you also write it as one statement. X is 2 over here. No, not 2 over there. -4 needs to be over there. 2 needs to be over here. So x is less than 2. -4 is less than or equal to x. Now our last example. 3y minus 5 is less than -8, or 2y minus 1 is greater than 5. Same exact thing, except they're not combined because they can't be combined because this is an or. So we still have our 2. This is already our compound inequality. We already have the first step that we normally do up here done for us already. So we're just going to solve these just like normal as a 2-step equation. Or and then we graph it. We're going to put -1 over here, 3 over here, -1. Making sure they don't overlap, because if they do, our final graph changes. Y is less than -1 for 3, y is greater than 3. So that is our answer right there. Now, back to student journal. I'm going to go through 5 more examples. I want you to try these on your own first, and then I'll go through them all. So if you want to try them on your own, pause right now, because now I'm going to start going through them. So this first one, we know it's an and. I'm going to split it off into our 2 equations. 4 less than x minus 3. Make this thinner actually. 4 is less than x minus 3. X minus 3 is less than or equal to 7. These are both 1 steps, so should be fairly quick for you, hopefully by this point. If not, that's okay, as long as you can figure it out. and these are ands. And then if you wanted to, the optional combine it into one statement. And this is how we would graph it. Let's put 7 right here. Let's put 10 right here. 7 is an open circle. 10 is a closed circle. Let's double check they overlap each other. So we have x is greater than 7. That goes that way. X is less than 10. That goes that way. They do overlap. And this is where they overlap. If you want to do the ultimate shorthand, because as you can tell, we do the same exact first step to both sides. We're adding +3 to all sides everywhere. So when you have something like this, you can think of it like, even straight from here, you're dividing everything by -5. But you have to be careful when you're doing that, especially in a case like this, where you're dividing everything by -5. That also means all of the signs flip. So here, we would have -3, sign flips this way, g, sign flips 2. And if you wanted to write it out into the compound inequality, you can if you really want to, where you have g is greater than or equal to -3 and g is less than or equal to 2. Double check they overlap each other. This one would go this way, this one would go this way. So they do overlap. Where do they overlap? Right here. Now for the ors, compound inequality, same thing. So let's do, I'm just going to do the work from here. -4 on both sides, so x is less than -2, or dividing by -3, dividing by negative, the sign flips. Oops, not x, z. Z is greater than 8. So if we have -2 here, 8 here, open circle at both, double checking that they're not overlapping, because if they are, our final graph will be different. -2, less than goes that way, greater than 8, greater than goes that way. Now one of these is a 1-step, one of these is 2-step. Subtract 6, c, 2t is less than 4, divide by 2. So we have t is less than 2, or, actually I guess both of these are 2-step. T is less than 2, or subtract 7 from both sides. We have -t less than or equal to -5, divide by -1. Sign flips, dividing by a negative. So we have t is less than 2 or greater than 5. What I'm going to do, because I kind of wrote really close to the number line here, I'm just going to graph it over here instead. Let's do it one more even. I can even do it like this. I have 2 right here, and I have 5 right here. 2, open circle, less than 2, t, closed circle, greater than 5. Now this last one. It looks scary, I know. We have multiple ways we can do this one, actually. So if you want to split it into the compound inequality, like we've been doing, like for number 6, I'm going to do myself a favor because I know both of the inequalities are going to have that center part. So I'm just going to save myself some time. I'm just going to distribute out that center part first. We'll do the work down here. 1/3 6x plus 24. We'll go switch back to the thin one. So what I tend to want you to do is to distribute first, right? Because that's the safer way. So we have 1/3 times 6x plus 1/3 times 24. If you remember, a whole number times a fraction, it's the same thing as the whole number part times what's on top. So we have 6x over 3 plus 24 over 3. 6x divided by 3, it's just 2x because you have 6 divided by 3. If you really want to, because that's also the same thing as 6 over 3 times x. Plus 24 divided by 3 is 8. So that whole thing simplifies to 2x plus 8. So from here, I can split this into negative 8 is less than or equal to 2x plus 8, and 2x plus 8 is less than or equal to 12. I'm going to solve these out first before I show you another way you could do it. So we have negative 8 is less than or equal to x, and x is less than or equal to 2. Another way you could do it is along the same vein as what I was doing over here, where whatever you do, you just apply to everything, just making sure you keep track of what you're doing and what the rules are. Or instead of distributing, you could just multiply by 3, because what's the opposite of dividing by 3 is multiplying by 3. So if I just erase this real quick, what we could even do, I'll do this in purple, we just multiply everything by 3. If I multiply this by 3, multiply this by 3, multiply this by 3, because that gets rid of this. Why isn't it showing up here? Oops. So because that gets rid of this. So we could just simplify this down to negative, I'm blanking, 24 is less than or equal to 6x plus 24 is less than or equal to 36. You could just solve from there if you want to, the same exact way. Subtracting 24 from all sides. Negative 48 less than or equal to 6x less than or equal to 612. Divide everything by 6. So this side we would have negative, do I know my data? This is 4. Wait, no. 4 times 12 is 48. What am I doing? 48 for 6 is going to be 8 less than or equal to x less than or equal to 2. And wow, would you look at that? This answer is the same exact thing as this answer. That's just another way to do it. If you want to save even more steps, I will accept this, but if you want to do the safer way is just writing it out into its compound, because this does require you to remember to keep track of a lot of things. So if we graph this, put it back to green, let's just put negative 8 right here, and let's put 2 right here. Because it's an and, gotta make sure they overlap. Close circle, negative 8, it's greater than negative 8, so that's that way. Close circle at 2, it's less than 2, so it goes that way, and they do overlap. Where do they overlap? They overlap right here. So, wait, I had all this space over here on this side. I feel... So, in summary, compound inequalities, they are inequalities that are, actually the notes are over here. Two inequalities joined with and or. And is when both of the inequalities have to be true, so it's where they overlap. Or is where either one of them can be true. They don't have to be true at the same time, just one of them has to be true. And then you can just solve and graph them like normal. There are some special cases for if you have an and, but they never overlap, it's no solution. If you have an and they do overlap, but only one part, remember you're only graphing where they overlap. For ors, if they overlap each other, depends on how they overlap each other, because it's just where one of them is true. So if it's where one of them is true and they overlap in opposite directions, it's all real numbers. If they overlap in the same direction, then it's basically the one that is more encompassing than the other one, the one that covers more space, because only one of them has to be true. One of the inequalities has to be true. Went from words to compound inequality, and then we solved compound inequalities. So now I'm just going to go back real quick to the hardest problem that I had here. I'm going to erase this part so I have room to work on it. You should be able to do this by now. It's still a little bit harder, but if you remember from previous lessons, you should be able to do this. Pause right now if you want to try it again. But from here, I'm just going to start doing it. I'm going to do this just in my own way, which is a very fast way. I'm going to combine a lot of steps into one. So I'm going to solve this first inequality. We're going to be, like I said, combining a lot of steps into one step. Combining like terms. So those cancel out, these also cancel out, these also cancel out. So we got a 0 over here, 6k divided by 6. 0 is less than k, or k is greater than 0. Or, other side, I'm going to subtract 4k from both sides. I'm also going to subtract 8 from both sides. So that cancels out, that cancels out. 11 is greater than 11k. Divide by 11, 1 is greater than k, or k is less than 1. And this is an OR. So if we graph this, let's see what happens. If this one is pink, so we have 0 over here, open circle, it's everything greater than 0. Purple over here, we have 1, open circle, it's everything less than 1. Hey, this is one of the special cases we talked about. So our answer is actually going to be this. That's all real numbers. And that's what the graph would look like over there. So I want to have my scratch work here again. Only one of them is true at all times. So there you go. There's lesson 2.5, compound inequalities. If you understood inequalities up until this point, this shouldn't be too bad. It's just adding a little bit more on top of that. So as usual, if you have any questions, if you still have me, you can ask me next time I see you. If you have my email, you can email me, leave a comment, send me a message on Canvas, Google Classroom, whatever. I'll see you guys next time.